Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're talking about nuclear chain reaction, guys. So, put down today's title, it's going to be nuclear chain reactions. And before we get going, guys, make sure you hit the like and subscribe button, guys, obviously to keep my content free and share it with as many people as possible. Right, so let's have a quick recap before we move on. Okay, so previously in the course, guys, we talked about nuclear fission. Nuclear fission is when a large nucleus is split up into two smaller lighter nuclei. And we said that for uranium over here, as you can see, we've drawn it over here, if we fire a neutron into the uranium, so here's my neutron, let's color it green just to make it a bit nicer for you. So there's the neutron. If we fire it into the uranium, so there we have it, the nucleus is here, neutron goes into it. This nucleus will then become unstable, so the uranium nucleus becomes unstable. So let's put that down, and that's why I put the little arrows there. So it becomes unstable, and after it becomes unstable, it will break down and decay. And as you can see, it's split. There we go. And what happens is it breaks down into two lighter nuclei. Let's just color them purple right now. So this one's purple over here. This one is krypton, and this one is barium over here. But what also pops out is going to be three extra neutrons. 1, 2, 3. So here are our three neutrons which are coming out here. Obviously, you have the energy being released as well, so plus energy. That's the whole reason why fission takes place. So there you go, that's why I've got the yellow over here. So one neutron goes into the uranium nucleus, and then it becomes unstable, it splits, releasing krypton, barium, and three neutrons, guys. And this process is known as induced fission, yes, because you are triggering it with the neutron. So the neutron goes into the uranium, therefore causing it to split. Okay, so what exactly is a chain reaction? A chain reaction is the following. Imagine you do something very small, and when you do it, it triggers multiple events from that initial input. It's the same principle in nuclear chain reactions. You're going to do one thing and it will trigger multiple things to happen. So you only do one thing, but it triggers multiple things to happen. Well, you can kind of guess what will happen using what we have here. It's something about the neutrons. From one neutron being fired into the uranium, we can trigger multiple things to occur. And we'll look at it with the following diagram. So we're going to scroll down and look at it. Okay, so as you can see, we've got the neutron on the left-hand side and we're going to fire it into the uranium. Okay, we know it splits by nuclear fission and it will release three neutrons. Three neutrons come out and you have the krypton and the barium coming out as well. But these excess neutrons, these neutrons over here, well, we can do something quite clever. We can put them into other uranium nuclei. So these neutrons can then go into other uranium nuclei. So let's draw it over here. So there's another uranium nucleus, uranium. I was going to put U down for uranium, so let's put down one uranium there, another uranium there, and another uranium there. And then these guys will then split themselves. So look, this one will split. There we go. So this makes its own krypton and barium. There we go. So okay, so as you can see, guys, I've tried to draw it out here. So I've tried to draw out the next chain of events. So once again, one neutron goes into the uranium then becomes unstable and splits and releases three neutrons, 1, 2, 3. We don't really care about the krypton and barium for now, but those excess neutrons release, they will then go into another uranium nucleus, 1, 2, 3, each one of them, and they will then split into 3 each time. So look, what's going on here? We can see that when one neutron goes in, it triggers multiple events to occur. And this is really interesting because we know that with every single fission, we get energy here, we get energy here, and we get energy here, and we get energy here. So we're getting more and more energy each time. And obviously these ones can then go for the next set of fission processes. So here are this one can go to this one, we'll go to this one, they'll go to another uranium, 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 and uranium. And these ones will also go into their new uranium ones over here, uranium, the next one uranium, and the next one uranium here. And these ones will also go into the next uranium, 1, 2, and then these uranium nuclei will then split, releasing more of their own neutrons. So as you can see, guys, we've drawn the next iteration. We can see that more neutrons go into other uranium nuclei and those will then split themselves. So look, we're getting more and more each time here. Obviously, and each time we're getting energy. So look, we're getting loads more energy this time here. But the key thing is this: every time a fission process occurs, so every time there's the split, energy is released. But obviously, that can actually be uncontrollable because you're getting so much energy released here. So you will have to control this rate of the nuclear reaction. So because there's so many occurring right now with this chain reaction, from one neutron being thrown in and all the decays occurring, the nuclear reaction may become uncontrollable, guys. Because look, each time fission is occurring and we're getting loads and loads of energy, and it might be really difficult to contain that energy here. So obviously this is great because we have a chain reaction. So this is a nuclear chain reaction, and obviously it's because the excess neutrons release then go on to make subsequent decays. They then go into other uranium nuclei each time. So this is going to be nuclear chain reactions over here. There we go, nuclear chain reactions. All right, so problems. This may become uncontrollable because there's so much fission taking place. The simplest way for you to control the rate of this reaction is by absorbing some of the neutrons. So look, imagine right now if I deleted, if we absorbed this neutron over here, it would delete all of these guys over there. There we go. So look, we've deleted all of them over there. Wonderful. And look, now it's a bit more manageable here. And obviously, if I were to delete, let's say this one over here, it deletes this one over here. So if your reaction is becoming a bit uncontrollable, you can simply absorb some of those neutrons to control the rate of reaction. So let's put that down. So there you go, guys. The rate of the reaction can be controlled by absorbing the excess neutrons, guys. So the rate of reaction can be controlled by absorbing excess neutrons. Okay, so let's have a quick recap right from the top. Okay, so today's title was going to be the nuclear chain reactions, guys, and we started off with a quick recap upon what we covered previously in terms of nuclear fission. Let's put that down actually. So previously we did nuclear fission, everyone. Yes, nuclear fission. And it's the process in which we fired one neutron into a uranium nucleus. It then became unstable and it split, and it released krypton, barium, which are lighter nuclei, and 3 excess neutrons were released, guys. So 3 neutrons were released. Obviously you get energy as well. That's why I have the yellow over here. Right, from here, guys, we said, what about a chain reaction? So we can get a chain reaction occurring from this whole process. So we can see that, look, if we were to take this right now and just look, we were to take those excess neutrons and fire them into other uranium nuclei, they will then split themselves, releasing more neutrons. So look, on the left-hand side, 1 neutron coming in, goes into the uranium, it then splits, releasing krypton and barium and the 3 neutrons. If we take these neutrons, they go into another uranium nucleus, they will then split themselves, and then those neutrons can go into other uranium nuclei, splitting them as well. So look, it's a chain reaction. From one initial input, we have multiple events occurring. So look, it happens here, along this branch, and the other branch at the bottom. Notice with every single fission, which is the split, you get energy being released. And obviously, you've got to manage this as well. So nuclear chain reactions can become uncontrollable. So the simplest thing we can do is to simply absorb some of those excess neutrons, guys. So if I was to, let's say, delete this neutron here, it would delete this all path over there. So look, we can control the rate of the reaction by absorbing the excess neutrons. And obviously, if I delete this neutron over here, we can also delete all of these reactions over here. And now look, it's much more manageable, guys. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your studies. Goodbye.